Untold Unix story. What is this? Hello, I'm Chris Ness. I'm a KMP developer. Tech support said they're coming out to fix close that soon. Oh, I'm on the other side. Today I'm going to be doing a watch along of a video I've not previewed yet by DJ Ware, who is very like he used to be like. I mean, well, at least he was very influential. He's all over the place. I don't know if it's the same DJ Ware that did all those kind of sort of like lots of different open source things. Let me flip my guy here. Um, uh, and he's definitely knowledgeable. I kind of skipped over the Unix phase because I wasn't in academia at the time. I was doing microcomputers like Mac OS, and I building IBM PCs and stuff. So I was in the more of the commercial side, commercial world of things, and then I did consumer software at these companies. So I was doing all micros computers. So I came in to Unix after OS 10. So I was like, I still avoided all trying to get into it because it felt like just another DOS to me with all the crazy little weird idiosyncrasies to it, and I was like, I avoided it for a long time. Eventually, I embraced it like you have to because everything runs on Unix, and basically the Unix idea. So let's hear what he has to say.
I want to talk a little bit about something on my mind about operating systems and how they're being taught. Also, some of the existing operating systems that we have that haven't changed in 30 to 50 years for most of them. So
Yeah,
to me, that is pretty
the
long in the
list
tooth.
one.
But there are some operating systems that are being developed today. But I want to talk about an untold story on the commentary of Unix.
Whoa, a little loud.
And
Sorry
there's a
about
famous
that.
quote that appears in this untold story. So I want to let you know what it is ahead of time. You are not expected to understand this, and that was a quote by Dennis Ritchie. So we're going to explain that at the end. So just stay tuned, and we'll get going here. But before we do, let me just explain that in 1968, it seems like it's always funny how things in the computer industry kind of build up. There's all these blocks that kind of fall into place as technology is approaching. So
I mean, it's not approaching. It's like we're building every little piece based on the last thing we just did. You should know that. It wasn't just fell into place. Like, no, you had individual people who were super into it at that moment, at that time, and they were pursuing some project, some problem, and they got fascinated with this thing, and then they just built on the last thing that built on the last thing that built on the last thing. And it wasn't this, oh, it just fell into place. Like everyone's like coordinated effort. It's like, no, it was definitely a organic, bottom up. Even just the whole story of Unix and Dennis Ritchie with his C quote, you're not expected to understand this. It's like, maybe the thing is he didn't feel like explaining at the time. Like he's a really good explainer. It's like his code's awesome. But maybe at that moment he was like, I don't want to dick with this right now. I gotta get this paper out. Let's keep going.
one of the blocks that fell into place was in 1968. There was an article.
Blocks that fell into place. Like that terminology is like maybe it seemed like from the outside that blocks were falling into place, but this is people spent many hours, weeks, days, months, years trying to develop these things to get them to come to, and then there was a whole bunch of so many people doing the same stuff. Most of it was garbage or just for their particular thing, and there's a few people like Dennis Ritchie and what's the other guy? What's the other guy's name? Yeah, Ken Thompson. I don't know why I can't remember his damn name. Yeah, Ken Thompson. So Thompson was had the idea like, man, we can make a new operating system. We can start over from this batch crap, and we can do our own command line, interactive, interpretive thing. And Dennis Ritchie's like, hell yeah, but we got to get away from this assembly language because the only way this is going to take off if it's portable. If we try and make it for just one machine, we're going to be like Thompson down the hall, who's made his proprietary system only in assembly language for that particular box. We got to make a universal box. They're like, yeah. So the same thing happened with KMP, by the way. They're like, we got to make a universal layer that has all this common shit that we always do, and every single one of these things, except we rewrite it in an assembly language. Let's make a common language that can do right to all these operating systems at the same time, or have one common core of it, and they'll have the edge stuff be little separate things for each dang little operating system, different way of implementation it for each assembly language, right? We have the common core stuff, and then we can go and we ship it off with 100 different places, and we can get away from this proprietary batch stuff, which has honestly seen its time because we've been doing that way for like 30-40 years at that point. Let's keep going. I gotta click on the right screen.
That was published by the ACM. And these are quotes by a man by the name of John Lyons. He was a professor at the University of South Wales and taught 2 courses in operating systems and their design and how to build them. So what he was talking about here, these are quotes from him. He said, there seem to be 3 main approaches to teaching operating systems. First, there's the general principles approach, wherein you lay out some fundamental principles, you expound on them, you give illustration by references to various existing systems. Most of
like how RAM is laid out, how you can like have a RAM scheduler and have how disks are laid out, and how you can like lay out information, but it was always this technical part of it. It's like, yeah, but how do we as humans think about these things? Like, well, we're bound to this hardware, so we got to do these implementations to hardware. It's like, it was there, got really tied into the hardware. It's like the most important thing. It's like, okay, that's just one way of doing it. Let's keep going.
which are outside the student's immediate experience. And this approach is advocated by the cosign committee. But in our view, many students are not mature or experienced enough to
Yeah, if you're on the committee and you've been running on these systems, yeah, you're gonna have a lot to say about how they're put together. But like general principles that were created that system, how do you even document that? That's all tacit knowledge. People trying crazy ideas that don't make sense, like the fact that Ken Thompson was built a schedule for an old computer that nobody was even using. There was a lot of guys messing around with stuff like that. That it went nowhere. But why did his stuff take off? Well, because the approach he took was like, we need to make a universal layer that gets out and gets rid of these tiny little silos of these assembly language programs. We're all doing the same damn thing. That's what they figured out. It's like, oh, all doing the same thing in the same bunch of different ways, doing the same damn thing. It's like people before they had a standardization on a screw, like they were all making their own screws that had to be matched to the right nuts, like all that stuff.
From it. You don't actually get any hands-on. This is the type of operating system training that I got initially in a course by a university, was to look at OS 360. Well, first of all, OS 360 by the time I took it was defunct, and second, there wasn't anybody around in the local area that was running it, so to go see how the thing actually ran.
Right, but that wasn't what it was designed for. It was designed to put those people on a committee so they could have their name on their badge, so they could get up to fellow, be an IBM fellow, and they had to look real impressive and super impressive to people who understood it. People up on the outside looked in, they're like, "Wow, these guys are just freaking Greek. We have no idea. It must be really impressive." It's like, no, they're all talking about the same shit. Round and round, except one's using this assembly language, one is using this assembly language, or this operating system over here versus this one over here. Their implementation details are just totally irrelevant.
So yeah, we looked at bits and pieces of it, but never the full thing. So it was kind of disappointing, and I went off and studied operating systems on my own. So the second approach, the second part of his quote.
That's what Richie did. That's what Dennis Ritchie and Ken Thompson did. They didn't want to screw all this stuff. This stuff is all nuts. It's all like embedded in the hardware. It's like, what is hardware? What is software? They started like doing all these functions in hardware. It's like, why are we doing this stuff? It's this. Why this is overcomplicating everything. So that's when they ripped it down and put it down to the minimalist stuff. That's why it was Ken Thompson and Dennis Ritchie to do it, because those guys are minimalists, man. It's like focusing on the solution, focusing on the problem. What do we have at our disposal? Cut everything else away. Awesome.
The second approach is the building block approach, where the students are enabled to synthesize a small scale or a toy operating system for themselves. And he says, while undoubtedly this can be a valuable exercise if properly organized, it cannot but fail to encompass the complexity.
Well, no shit, man. So you're saying that people should not build these things up from the ground up to understand how they truly work? Like a little Lego engine, you get a regular engine, move to a bigger engine because you know how they work, how they put together. Come on, this guy. So this is the kind of stuff that stopped. This is the kind of thinking, this particular line of thinking where, oh yeah, but it doesn't have all the details of all you need to do. It's like, no, it has enough. The fact that Ken Thompson was able to put together a Unix operating system based on a scheduling of a disk, yes, it's enough. Because that was a toy. He just started building together. He's lucky to have Ken Thompson around, Dennis Ritchie around to get out of the assembly mode, because it wasn't his skill set, man. It wasn't his skill set, but it was definitely Dennis Ritchie's skill set to really do languages. He was totally into it. He's good at it too, man.
Sophistication of real operating systems, and it's usually biased towards one aspect of an operating system design, such as process synchronization. Again, the operating system I took, that's what they concentrated on, was how to synchronize processes in the runtime. So I know this one well. Yeah, it was kind of disappointing on that course. So anyway, the third approach is the case study approach, and this one originally was recommended by the systems programming course in curriculum 68. That'd be for 1968. This was the report of.
I was born in 68, so I skipped all this stuff. But he was in the thick of it, trying to figure out this stuff, like between the hardware, the software, the documentation, and communication, and different ways of thinking about how these machines are supposed to work, from batch to like real time, online, time shared. They're all crazy. The people are just like hold on to those old things because they already have a department and a budget, and they want to like keep going just to how things were before. And it's like, no, we're gonna do a universal architecture and throw all that stuff away, and your specialized knowledge that has no more meaning. It's so brutal. This industry is brutal.
ACM Curriculum Committee on Computer Science that was published in March of 1968, and the issues of the communications of the ACM. And the third approach was always considered to be the holy grail, because then you're taking an operating system that exists. It is something that you can get your hands on. You can compile it, you can modify it, you can play around with it, you can break it, and you can see what happens.
That's how you made it go viral. That's why these systems went viral. That's how people got a hold of this stuff, because it was in their ivory towers. Nobody cares except for the people in the ivory towers who want to maintain their moat, right? So they can keep their budgets coming. But once this stuff gets out, and this is how it gets out by people, they go like, nah, you shouldn't really be keeping that in an ivory tower. It's really like just let anybody have it, and then boom, it's out. That's how the stuff gets adopted. Not, oh, we're gonna do licensing fees, and the big corporations are gonna get involved. It's like, no, that's not how that's not how Unix spread. It was totally not like that. The only reason it spread is because it got academics, students could compile it and look at it, look at the source code, and then there was a documentation of which I'm sure he's going to get into, which made it obvious, like, oh, this is what, oh, this is why this is this way. Oh, now I understand. It's written in C and some universal things. You don't have to learn all the assembly language crap. It's crazy. And all I had to learn was the C stuff. And then somebody went through the document. It's like, hell yeah. It's like the first open source type of thing, and it went crazy. And they tried to redate it. I'm sure you're going to get into it, but they tried to like reel it in. It was like, nope, too late.
That's always the best way to learn. I mean, if you don't have a hands-on approach to learning something,
Yeah, of course.
concepts in esoteric design, nah, you're not gonna learn anything that way. You learn things by hard by actually getting your hands
You can prompt your way to make an OS. You're going to prompt it.
in there and trying to do it. The second wheel that kind of turned was Bell Labs had left the Multics project, and Ken Thompson, Dennis Ritchie, and Douglas McElroy were all out looking for something to do, and they were all Bell Labs employees. So
And they found something.
they were considering they were kicking around ideas for an operating system and what they thought it might need, and they went out looking for some hardware, but they really wanted to go get their own machine, but management was like, nah, you're going to have to show us that this is going to have some
Losers. That's why management, they can't see the vision of these things because they're so stuck in there like, no, we got to do it the proper channels, and yeah, you don't want to give you the budget for that, so go ahead and give up. One of the guys in Bell Labs like, you don't understand, we're clever suckers. We're like one of the most cleverest people on the planet, and you're telling us because we don't have budget when they got all these machines laying around? Come on, guys.
some kind of benefit because we just came off of Multics. We spent a bunch of money. We didn't get anything out of it. So yeah, they were a little burned.
Well, yeah, because the way you did it, guys, it wasn't that Multics was bad. It's the way you tried to put that thing together. It was never gonna. It was impossible. It was almost like somebody sabotaged it.
Really weren't too interested in this. So they came across a machine that was a PDP-7, which that would be like 3-year-old vintage equipment, probably even 4. So I mean, it was pretty much obsolete. It wasn't being used for much. There might have been some people using it, but it was kind of
wasn't used at all. That's what Ken Thompson says. It was in a corner collecting dust. Nobody turned it on. Nobody cared about it. It was abandoned. And he took it and he made magic with that freaking thing. Incredible.
I want to be on that one. So they kind of procured that one and started working on developing Unix, which they completed at the end of 1969 and released in January of 1970. So and so in May 1975, Bell Labs released Unix System 6. This was a watermark release because it was the first Unix to be released outside of Bell Labs, and so this was their commercial offering. This was the one.
This is the thing that
the Programmer's Workbench.
And they had 6 versions of it, which is awesome. So they got all the bugs and all the kinks worked out of it, and it was pretty rock. It was definitely like battle hardened at that point, and then that's when it escaped. Hell yeah.
A commercial version of Unix that AT&T could possibly sell. However, AT&T was constrained by their monopoly decree. They were not allowed to enter the computer industry or any other industry other than communications in any way, shape, or form, or they would be in trouble with their antitrust suit. So and so they kind of pushed this over onto a wholly owned subsidiary called Western Electric, which they also offered it to universities for free.
Oh, that's what Western Electric was. Oh, that's why I was like, what is this electric company doing with Unix? I'm like, now it all makes sense. Okay, this is why they ended there. It was all this legal wranglings and breakup and of monopolies. They were badass back then. They were kicking ass for a century.
Gave them the source code. One of the interesting things about System 6 was not only was the source code there, but universities could teach with it. They could use it in a classroom. It was permitted by the license. Well, John Lyons in 1976 caught on to that and went, I think I'm going to use this for one of my classes because now I've got essentially a stage 3. I can actually let my students get hands-on and play with a real operating system that is functional. So he created this paper called The Commentary on Unix 6th Edition.
This thing, that's what made it, that's what kicked off the current revolution or the current style of programming is this bad boy right here.
And he actually took the source code, went through it line by line, and had text that explained what everything did.
That is so badass. Like, if it wouldn't have been for him, you definitely would not be using Unix today. We'd be using some mainframe somewhere online, and we wouldn't be doing it like this. So that's badass, man. It always takes a Pied Piper, someone explaining what all things work to make this stuff happen. There's always somebody like that. There's always one person who took time out of their life to do this for whatever reason. Nobody told them to. I'm sure nobody's like, you're gonna write a source code, blah blah blah. Like, you should do this. Like, nah. How is that even gonna? How would you even do that? It's like, we're gonna budget. We're gonna scour the internet for. We're gonna go scour the town hall from someone who can document the source code. And Dennis Ritchie and Ken Thompson, their genius shit. how does this stuff? It's like you can't predict. It's like all of a sudden it just happens. Like yeah, someone took time out of their life to do something. Yes, they got credit for it, but also epic and unexpected and uncontrollable and courageous. It's
This particular
adventure
operating
driven.
system still had assembler code in it. It was I'd say maybe 90% C, but it still had about 10% assembler in it. So it was kind of married to the PDP-11 architecture because of the assembler, and
That
that
was
was
soon
fine. He was good with
rectified.
that. So he put this paper together, and he typeset it, not using nroff, because he didn't know how to use that at that time. This was new for him, too. He published a paper, and that paper basically, as we would say today, went viral. I mean, the universities were going crazy. They all wanted it. They were like
Well,
grabbing this thing up, and they
yeah,
were
you have a full source code to an operating system, and it's not proprietary, and you don't have to pay for it. You can just look how it works, and then you might be working on one of your own things because it was a big deal back then to have your own operating. It's sort of like these frameworks. It was like having your own framework instead of having a framework that only worked on one operating system, like like the iOS like Swift stuff. You have something like KMP, it worked on them all. And people went nuts. Of course they did. Once they figured out what it was, and then there was no licensing fees, and the source code was documented. People they flipped their lids because you took something that was $1 million minimum for one person to even just think about it. Like I gotta get $1 million. And back then that was a lot of money. Just to get access to this stuff. And even if they did get it, it wouldn't be documented like this. Like some academic went through it that was like super into it and he took his time out of it. He did like his magnum opus was documenting these things or this genius level work. Come on, how do you? It just kind of happened. Like, yeah, it just kind of happened. We should be grateful. It's not like, oh, it's just how things work. It's like, well, maybe, but if you're lucky, for how many of these things have been exposed and nobody just we're just falling away, like Hypercard and Supercard. I love those platforms. Like, they just nobody used them anymore, and the corporation killed it, and that was the end of that. Proprietary. Bye.
They were tearing it apart, looking at it, just having a good old time with it. So it exploded. Here's what he said. He said, not least among the charms and the virtues of the Unix time-sharing system is the compactness of the source code. The source code.
The compactness. You mean the understandability, right? So we can understand like a block of reams and reams of assembly. We have no idea what it's doing. Push the X into XA. What does that comment even mean? This is useless comments. Well, you hired us to write the software, not comment on it and explain it. That's for it's obvious. Just look at this assembly. It's like, dude.
Code for the permanently resident nucleus, that is the kernel, of the system, when only a small number of peripheral devices are represented, is pretty small. It's less than 9,000 lines of code. And he said, it's often been suggested that 1,000 lines of code represents a practical upper limit for a program which is understood and maintained by a single developer. So, and I paraphrase.
Right. Well, yeah, that's pretty, like, back then, yes, 1,000 lines of coming out text one at a time. Yeah, it was pretty gnarly. But these screens are, hundreds of thousands of lines is now acceptable. Let's keep going.
Basically, what he's trying to say is that this is perfect. It's small. I can give it to a small team of students. They can go in and actually work.
Understandable. The cognitive surface layer was now understandable. It wasn't years of begging to get into an ivory tower behind the scenes and specialized knowledge, and then you're stuck in some role that you don't even want to be there because all you want to know is how this stuff works, and you're like, nope. You have to pay all the fees. And then this guy comes out, no, here it is. Here, no fees. There you go. Do what you want with it. No pay nobody anything. People went nuts.
I can give them an assignment, they can make it work, they can bring it up, and they can demonstrate it working on a PDP-11. So he rapidly became the most copied paper in computer science ever. There were literally thousands of copies that were floating around using that at the time that you could pull it off. So it's still around. You can find it today if you just search for it. So in 1977, he published the work as a book. And the funny thing is that went viral too. Everybody was grabbing it, not just universities, but even people out in the...
For good reason. You just gave away $1 million thing. You gave away something it took years of effort, if you were lucky, to get access to the golden key to get into the room, like Ken Thompson did, to go explore these things and go, what the hell is all this bullshit? For what we're actually trying to do, this is way too much, guys. Like this is our technical. This is our solutions. This is how we do it at IBM. We do it. We have to have a ivory tower, and you shut up. And like that, so this stuff gets out, people can do it on the $30,000 piece of hardware they have sitting around in the back they haven't been using years because it's too crappy to even deal with because you have to write everything in a proprietary assembly language that you can see that runs it, and you can do all this crazy operating system stuff. So yeah, what do you think's gonna happen?
The system engineering field, the developers that wanted to understand better how the operating system worked. So it was flying off the shelf. They couldn't keep...
Right, because it was proprietary knowledge before then. There was nobody doing... This is the first one. Nobody had... This was kept hard close to the chest. This is family jewels. This is billion-dollar software. What are you talking about? They just let it go up for free.
Keep up. They couldn't keep up with the demand to publish the book. So John finally threw up his hands and he talked to, I don't know who at Bell Labs, but he finally got them to agree to publish the book for him because they were the only place that he could turn to that had printing facilities that were large enough to be able to meet the demand. And so in 1978, they were the only place that you could get the book was from AT&T Bell Labs. Well, things changed. In 1979, Bell Labs
that was the final block, the last hurrah. The only reason we even know about AT&T anymore is because they let this out and they didn't take the $1 billion. They gave it to people. And they made so much money. They were fine. But like, with that, the only reason we're even under their name, and even they have any relevance at all, because they did support this effort, and people do appreciate them for that. People involved with that, even though the company now is totally, it's not even clear close to any of this stuff. Let's keep going.
Unix System 7. This was the first portable version of Unix. They removed all of the assembler code, replaced it with C, and now it was able to work on DEC BDP11s and also the new VAX machines that were rolling out from DEC. They also ported it to Intergraph and a bunch of other machines. So the Unix environment at 1979.
Who they did or people did? Once you got C, man, and all you do is write an assembly language interface for that, you're off into the races.
Started to expand rapidly into other computers. But Western Electric was kind of worried. They saw the book from John Lyons, and they were worried because they knew there was proprietary code in the Unix kernel. They were worried, so what they did was they revoked the use of the source code in classrooms. So you could still get the source code, but you couldn't use it to teach. And so that was retroactive. So and that was kind of unfortunate because now universities can no longer use John Lyons' book.
Somebody at AD was like, "We just gave $1 billion thing away. We gotta bring this thing back, guys. This could save the company. This could save the company." And they didn't realize, no, dude. The only reason why this is going viral is because you aren't owning it. Because it won't be $1 billion thing if you do it, AT&T. But they tried to retract it back, but it was already too late. They tried. They're like, "Oh my God, no!" Like, "Oh, too bad." But at least we remember your name.
The Unix 6 or 7 in order to teach their classes. So what happened? What always happens? There's all these copies of the photocopies of the book, and you know how the people are. So anyway, the students began meeting after hours, and they continued to use photocopy versions of both the book and the source code, and they would study it on their own. I
remember hearing people talking about this at the time. I was like, I was into microcomputers because we were just doing single threaded. We were doing other stuff, and these guys were totally all about this. They were super excited about it. I didn't understand at the time, but now in retrospect, I go, oh, that's what they were doing. Oh, okay, they're like how I feel about KP. Like, hell yeah. And mother people were like, no, not yet. Like, I don't know. It seems pretty legit to me. Like, and that's it's been that's how it is.
They would assign themselves projects and they would go and compile it, get working on the BDP11 or the VAX, whatever they had handy. And other universities just said, well, okay, fine, we'll revert back to teaching theory. And I think that's the reason why my class in it was stuck, because this had already happened when I had taken my class. So
then someone paid them off. These people like, hey, look, we'll give you a grant, but you got to stop touching this stuff. It's like, it's too late, man. This shit's out of the barrel. You should have let it go sooner. You shouldn't have messed with Ken Thompson and Dennis Ritchie so hard. You should have let them do this. You would have you might be around today, but you're too greedy and too selfish. But
fortunately, some professors like Andrew Tannenbaum decided in 1987 wrote a Unix-like operating system called Minix, and that allowed him to not only have an operating system available to teach operating system principles with, but allow users to get engaged with it, to kick the tires, play around, change things, and see how it would react. So today, Minix is open source. It wasn't originally, but it is today. It is open source under the BSD 3 class, and it's been that way since April 2000. I think the current release is Minix 3.3. If I remember serves me right, I think you can still get it. You can still download it. In 1991, Linus Torvalds released Linux for the x86-based PCs with full source code, but it wasn't at that time open source. There was a license under it, and I don't know how soon he did open source. It probably wasn't too long. Linux was licensed under GPL2 as an open source license, and it still is today. So right there, you have one that you're free to use, not only for your own purposes to change, but also you could use it to teach as well.
Again, one person, one person doing it. Like, there's not like 25 people doing their own flavors of Unix. It's just one guy. And it's like, oh, it's just Linux. It's just him. It's like, no, it's just like. That's courageous. Like, I don't know, people give their life to that kind of stuff. To make something like that, you gotta, to keep it going with it, you gotta kind of have to be this very odd type of person. We're lucky to keep having him. He can be a dick at times. I think he's hilarious. But like a lot of people don't get his humor. Let's keep going.
But there was forces inside of Bell Labs that wanted to get that book from Lyons republished. They had a whole bunch of things they wanted to add to it and update it with. And so Santa Cruz Operation owned the copyrights to Unix at that time. They finally did in 1996. They authorized the release of this 21-year-old epic 6th edition source code and the commentary. And Peer-to-Peer Communications published it. I believe that is still the same book you will find today. It's still offered. It's still been in print all these years. Why was this important back then? I mean, the operating system was kind of propped up because why? Well, the corporations back then, like Bell Labs, for example, they were interested in long-term goals. I mean, Bell Labs' whole existence, and by the way, IBM's Watson Lab, and there's number of other labs within IBM that do exactly the same thing. They were interested in long-term goals. Those labs were put in place to look down the road and to have technologies and products ready for
Yeah.
production use 5, 10, 15 years down the road.
If they
So yeah, we don't think.
can, if they can be not dicks about it, if they can support the people who actually can make that shit happen and not put ivory towers up all over the place. It's like they shoot themselves in the foot. They all kind of do this. Xerox did it, 18, they all do this shit.
That way anymore. We only think in terms of this quarter and next quarter. We don't. Yeah, it's like we're driving blind at 90 miles an hour,
Yeah.
or maybe we're just looking at the hood ornament, and trying to go as fast as we can. Well, sooner or later, that's going to pan out. I mean, that's short-sighted type of planning.
But that's what they know. That's all they know. We can't. It's very difficult to convince Wall Street to change their tune after they've had quarter after quarter after quarter of this successful. This works great. What do you expect? Well, we need a longer term vision. And I was like, no, that's not how this works, man. They just go out of business, and another company comes in and catches the wave.
And sooner or later, that will pan out. So those places were perfect to develop Unix, but they don't exist anymore. So where do you go? Who's going to do this? Where's the next generation operating system going to come from?
Somewhere where it came from the last time. Somebody snuck it in somewhere. And they put it together in their spare time, and all of a sudden it just appears. It's like, oh my god, I've been working on this for 20 years. It's like all of a sudden it appears, like, holy shit, where'd you get this? How does this come possible? And so Ken Thompson comes up and goes, well, I made a schedule on some old hardware nobody was using because my project got canceled. I couldn't convince people to tell them why they canceled the project, so I just went ahead and started doing implementing the exact opposite of what I was just on that failed.
And I think the best place to develop a new operating system is.
How long does that take? How long does it take for that to happen?
Free and open source community. Why?
We're lucky.
Because as a community, we don't care about long-term goals. We work on stuff to try to improve things for the rest of the community. We try to build things around an idea, a concept, or a design. And
some people do. Some people are trying to get a buck and trying to get out of here and get their kids through college and then have a couple of vacations a year and have a nice nest egg 401k lake house.
And push those forward, get feedback, get help, get design changes that get incorporated into it, or forked off into something else. So I guess the question is, what's running on your computer? What kind of how old is the operating system baseline that is running on your machine? One more thing.
6 years.
What about this line? You are not expected to understand this. Where the heck did that come from? So in the Unix system 6 code, there is a file. I think it's called slock.c, and it used a quirk in the PDP's ability to save registers from procedure calls, and it was a hack basically to speed things up. And Dennis Ritchie put in there, he said, you are not expected to understand this
because he did a hack. He didn't want to admit it's a hack, or he didn't understand how it worked, or he's like didn't want to get into all the details. I guess he tries to say it here a little bit, but like he's like, this is instead of saying this is fucked up and a hack, he's just a nice person because yeah, this is dumb.
And later on, when they got to System 7 and they were trying to make this portable to other systems, that part of the code broke, and so they had to redesign that and take that hack out. So, but that quote has always stuck. If you run into any people like me that's been around for a while, they'll know what you're talking about when you say that, because it was taken.
There's lots of inside jokes all over the place. Come on.
Challenge. Now. Oh yeah. What do you mean I'm not going to understand this? I'll prove you wrong. But that's not the way Dennis meant it to be. He was saying that I'm not going to test you on this because this was clearly a hack to try to fix a quirk, a quirky system, and so that's all.
It was his extremely dry sense of humor.
But the community took it as a challenge too. Oh yeah, I'm going to prove you wrong. I'm going to understand how Unix works. And I think that's what played into all the downstream effort that went into systems that have followed since. I mean, without that seminal work, I wonder where we would be. Would we have OpenBSD? Would we have FreeBSD? Would we have all of those licenses that came down from that? Now, they're not based on any actual Unix code, but they are based on elements of the design. And the only way they would have known that would have been from that book and others like it. And the second thing is, John Lyons did a heck of a service to the community by taking the time to go in and explain. I mean, if you're looking at assembler code, you can't always figure out what the heck it's doing.
It's like saint level stuff to do that. Like seriously, because of how valuable it's been to so many people and how many people have gotten value from those people. Come on, man, it's like magic.
Unless you're running it and stepping through it, because it can be really obscure. Like that one, like where it's doing a hack on the references from the procedure calls and saving them back into registers. You may not know that until you're running what it's actually doing. So, and the other thing is that if you get hands-on, things are going to make a whole lot more sense to you than trying to read them out of a book. But
no shit. Why do you even say that? That's obvious.
Someone kind of guide you and lead you along. That's always the best way to learn, right? Because you're going to have questions. You're not going to understand. Well, why is he moving this over here and then back again? Why is he doing that? There's reasons for all of those things, and sometimes it was just to cause a delay long enough for the system to update the registers in memory.
So, all that kind of tacit stuff that people don't document or embarrassed about or don't understand or just kind of hacks it works in there and you're supposed to try and justify it. It's like a lot of this stuff is just workarounds of stuff that we're trying to make it do stuff that was never designed to do.
I mean, there was things that were done like that in order to prevent us from overwriting code before it was, or overwriting registers before they were ready. But anyway, enough of that. I hope you enjoyed this talk today. I will leave you with one comment. I hope that some of you get interested in operating systems, because clearly this is something that needs to get done. I mean, I'm too old. I would love to jump in and do it, but I'm too old to do this now.
No,
I would love to get some of you involved in getting interested in this and taking something like this on to develop an operating system.
Yeah, I think the next operating system is going to have to involve this AI integration. It's going to have to be some sort of self-modifying system that allows us to change it for what we need and have some sort of system underneath. So these black boxes where we're only allowed a surface level access. We can't hook into these things very easily, or they really shun that and make that not a big thing. It's like the next operating system I think should have that more integrated. I think that's next. Like Alan Kay basically is what he talks about with this stuff. All right, give me a like and subscribe. I'll leave the link in the to the DJ Ware, and we'll talk to you soon.